Okay, we are now recording, and now let me go ahead and share my screen just to show you guys what's in Schoology and what we are going over for today. Okay. Okay, as you guys know, the fourth 6 weeks ended before spring break, so that was the end of that marking period. And so now we're in the beginning of a new marking period. We're in the beginning of the fifth 6 weeks. Okay, so the end of the year is vastly approaching. The year is starting to wind down. And it tends to just go faster toward the end after spring break. So now, even though we are in a new 6 weeks period, we are still on the same topic. We are still talking about waves. Okay, we're still talking about waves and harmonic motion. Okay, so we're basically continuing this unit into today, where we're going to deal with a subtopic of waves. Okay, so let me go ahead and click on the folder for today. So if I click on the materials tab, as you guys know, I have a new folder right here that says Fit 6 Weeks. Okay, so you want to click on that, Fit 6 Weeks. Okay, and we are in the first week of the 6 weeks period. Today is March 22nd. Okay, and it is a Monday. Okay. So as I said, we're continuing our conversation into waves. Today specifically, we're going to focus on wave speed. So not a whole lot of material not a whole lot of new material I'm going to be introducing to you guys today. Just know that we're going to be focusing on wave speed. I'm going to give you guys the equation for how to calculate wave speed, and then I'm going to open up this assignment for you guys. Right now, you guys should be able to see it because it's unpublished, but in a moment, as soon as we get done with this lesson, I'm going to go through and open up this assignment for you all. Okay, but we're going to focus on waves and wave speed. Okay, so let us begin by reviewing a few things. Okay, so before the break, we talked about harmonic motion. Okay, and remember what I said, guys. Harmonic motion is basically any process that repeats itself over and over and over again. And after we talked about harmonic motion, we specifically talked about waves, and we actually discussed, some characteristics of waves, crests and troughs, wavelengths, amplitude, and things like that. I'm going to briefly review those terms on today. But a wave will be an example of harmonic motion because it's a process that repeats itself. Anything that repeats itself over and over again can be modeled as a wave. Okay, and so remember whenever we were talking about harmonic motion, remember we talked about this. I'm going to show you guys this video clip because I want to remind you guys of what we talked about before the spring break, because we're still going to be using these terms on today. Okay, so remember when we talked about period and frequency? Okay, so for example, consider this Ferris wheel right here. This Ferris wheel is clearly an example of harmonic motion. Why? Because it's a process that's repeating itself. If you notice, the Ferris wheel just keeps turning and just keeps turning and keeps turning and keeps repeating itself. This is an example of harmonic motion. Now, guys, do you all remember how to calculate the period of the Ferris wheel? Well, remember what period means. Period means how long it takes to go one cycle. In other words, how many seconds does it take to go one cycle? Okay. And hopefully you guys remember the way we found the period of the Ferris wheel. We actually just took out our cell phone and we actually just, opened up the stopwatch on the cell phone. And then we waited till this yellow box came to the top and we started our stopwatches. Okay. And then once that yellow box went all the way around and came back to the top again, we stopped our watches. Okay. And then when we stopped our watches, that gave us our period in seconds. Okay. That's how we found our period. Okay. And remember, in order to find the frequency, we just did 1 divided by that number. Okay, right? Because frequency just means how often, whereas period means how long. Okay, so just something I wanted to remind you guys of. Okay. Now, opening up these notes for today. Let me go ahead and open these up. Okay, so last time after we reviewed period and frequency, we then talked about 2 different types of waves. We talked about transverse waves and longitudinal waves. I want to remind you guys of the difference between these two. In a transverse wave, the vibration itself moves perpendicular to the direction of the wave. Okay. In a longitudinal wave, the vibration moves parallel to the direction of the wave. And let me show you guys the difference between these two. Okay, so watch here in this video clip right here. I'm going to show you guys a transverse wave. Okay, look closely at the difference. Okay, so this is a transverse wave. Okay, so he's producing a transverse wave in a slinky. Okay, and guys, you can clearly see it in slow motion. Notice how he's sending pulses of energy through the slinky. And there we have a transverse wave. Okay. Guys, notice how that's different from a longitudinal wave. Okay, so we have the same slinky, but now in this slinky right here, we're going to be producing a longitudinal wave. Y'all see the difference? Notice how his hand is moving, and notice how the direction of the pulses are traveling. So y'all see the clear difference in slow motion. Okay, so in this case right here, the vibration is traveling parallel to the direction of the wave propagation. So let me pause this real quick. Okay. So if you guys look closely at his hand, okay, notice his hand. He's pushing his hand this way, and he's also pulling it back that way, right? So he's vibrating his hand in the horizontal direction, whether in the X direction. Let's say he's vibrating his hand in the X direction like this, right? Back and forth, okay? And guys, notice how the pulse is traveling. The pulse starts right here and travels from this end of the slinky all the way to that end of the slinky. So the direction of the pulse is traveling like this. Okay? So you guys should be able to clearly see that the pulse is traveling parallel to the direction of wave propagation. Well, parallel to the direction of vibration, I should say. Okay. So his hand is vibrating. Notice how his hand is vibrating. It's like he's pushing and pulling it, pushing and pulling it. So his hand is vibrating in the X direction, and the pulses of energy are also traveling in the X direction. Okay, so that's why we say the direction of the vibration is parallel to the direction of propagation of the pulses. Okay. Now, notice how that's different from the transverse wave. Okay. Look, guys, look closely in the transverse wave. Notice how his hand is vibrating now. See the difference? Right, before he was pushing his hand forward and backwards. Now he's just kind of just waving it like this. So here's the point that I want you guys to see here. In this case right here, notice he's vibrating the slinky in that direction. and he's also vibrating the slinky in that direction, right? So his hand is vibrating like this, like along the y direction. Okay, but guys, notice how the energy travels. So notice if you look at one single pulse of energy, one single pulse starts here and it travels from here all the way to there. So the pulse of energy is traveling in this direction. So the basic idea here, guys, is that in a transverse wave, the vibration, so in this case right here, the vibration is perpendicular to the direction the wave is moving. Okay, let me play this again. Okay, so notice his hand is vibrating like this. Like his hand is vibrating along the y direction, but notice how the pulse of energy is traveling along the x direction. Okay, so here the vibration is perpendicular to the direction of the wave. I'm going to say that again. Here, the vibration is perpendicular to the direction that the pulse itself is propagating. Notice how that's different for this situation right here. In this situation right here, his hand is vibrating parallel to the direction that the pulses are propagating. Okay. So this is a longitudinal wave. This is a transverse wave. Okay. So I want everybody to notice that difference. Okay. I want to remind you guys of a few terms. Okay. So I want to remind you guys what the crests are. The crests are the highest points along the wave. We call those the crests. The troughs are the lowest points along the wave. Okay. So these points in red, those are troughs. Okay. I want to remind you guys how to find the wavelength. Wavelength just refers to how long the wave is. There's two ways. Well, there's more than one way you can find the wavelength. You can find the wavelength from crest to crest, or you can find the wavelength by measuring it from trough to trough. Okay. Either way will give you the right answer. Okay. You can even measure from this point to this point, right? From the start of the wave to the beginning of the wave. Those will give you the wavelength. So from crest to crest or trough to trough. Guys, the wavelength just refers to the length of one cycle. Okay. And just so you guys know, whenever we're talking about wavelength, we tend to use this symbol right here. It kind of looks like an upside down Y. Okay. Guys, in fact, this symbol right here, we call this symbol lambda, and that means wavelength. Anytime you see an upside down Y, that means wavelength. Okay. So lambda means wavelength. It just refers to the length of the wave, or the length of one cycle, I should say. There's another term I want you guys to remember. I want you guys to remember the term amplitude. So remember, guys, amplitude is a measurement from the midpoint of the wave to the maximum. So that line in purple, that represents my amplitude, right? Because this is my midpoint of my wave, and this is my maximum point. So in this case right here, my amplitude is 4 centimeters. Okay. So guys, amplitude just refers to the height of the wave as measured from the midpoint. Okay. Refers to the height of the wave as measured from the midpoint. Okay. So height of the wave is measured from the midpoint. Okay, and again, just reviewing those terms. Okay. Now, here's what we're going to focus on today. Today, we're going to focus on what is known as wave speed, or wave velocity. See where it says right here? The speed of a wave, or the velocity of the wave, is equal to, and here's an equation I want you guys to remember. The velocity of the wave is equal to wavelength times frequency. In fact, let me write this down. because this is the equation we're going to be using today. So the speed of a wave, or the velocity of the wave, is equal to wavelength times frequency. Okay. So this is the, guys. This is the equation you're going to be, the main equation you're going to be using for your homework. Speed of a wave is equal to wavelength times frequency. And again, guys, anytime you see this symbol lambda, that means wavelength. Okay. And obviously F just means frequency. Okay. Okay. So this is the equation we're going to be using today. Okay. And guys, I want y'all to understand what I mean when I say the speed of a wave. For example, if you look at this right here, this transverse wave, okay. If you notice, there's a pulse that starts here and it goes all the way over here. Guys, whenever we're calculating the speed of a wave, what we're saying is, all we're doing, we're just figuring out um, um, how fast this pulse is traveling. I'm going to say that again. We're figuring out how fast this pulse is traveling, basically from, we're figuring out how fast this pulse is traveling, basically from this end all the way to that end. That's what we refer to when we're talking about the speed of a wave, just how fast a pulse is traveling. Okay. So how fast a pulse of energy is traveling through the slinky. Okay. That's what we refer to the speed of a wave. Okay. All right, guys. So let us just do some examples using this equation here. I'm gonna just do a few examples, and I'm gonna let you guys go. Okay. So let's start with this right here. It says a wave has a wavelength of 2 meters and a frequency of 1.5 hertz. Okay. So a wave has a wavelength of 2 meters and a frequency of 1.5 hertz. Okay, so these are like the questions you can see for your homework. So remember, if it says what is his speed, we just use this equation. Speed equals wavelength times frequency. Okay, so speed is equal to wavelength times frequency. Okay, we know the wavelengths. It tells us the wavelength is 2 meters. Okay. We know the frequency is 1.5 hertz. Okay. If you guys take 2 and multiply by 1.5, you're going to get 3 meters. So the speed of our wave here, I'm sorry, not 3 meters, but 3 meters per second. That's the unit for speed. Okay. So in this case right here, our answer is 2 times 1.5 is 3 meters per second. So that's the speed of this wave here. Okay, 3 meters per second. Okay, so guys, please be sure you get your units right whenever you're working this out, these problems out. Speed is always in meters per second. Sometimes it asks you to calculate velocity. You're just going to use the same equation, because speed and velocity more or less mean the same thing mathematically. Okay. Let's look at this one right here. It says a wave is 8 meters long and has a frequency of 3 hertz. Find its speed. So once again, speed is equal to wavelength times frequency. Okay. So we know the wavelength is 8 meters long. Okay. We know the frequency. The frequency is 3 hertz. Okay. So 8 times 3 gives me a speed of 24 meters per second. Okay. So my speed there is 24 meters per second. Okay. Let's do a few more examples. A wave has a period of 4 seconds. Find its frequency. We've already talked about this before the break, guys. Anytime you want to find frequency, frequency is just equal to 1 divided by the period. Okay. So if you just take 1 divided by 4, that gives me 0.25 hertz. Okay. Remember, the unit for frequency is always hertz. Okay. Let's keep going. Let's look at this right here. It says a wave has a frequency of 2 hertz. Find its period. Okay. Well, this is easy because remember, period is just equal to 1 divided by the frequency. Okay. So if our frequency is 2, what's 1 divided by 2? 1 divided by 2 is 0.5 seconds. Okay. And of course, your units are going to be seconds because you're solving for period. Period is a unit of time, so the units are seconds. Okay. Let's do a few more examples. Okay. Here it says a wave has a speed of 50 meters per second. If its frequency is 100 hertz, what is its wavelength? If its frequency is 100 hertz, what is its wavelength? Okay, so let us write down our equation for speed first. Speed is equal to wavelength times frequency. Okay, now guys, so here they're asking us to solve for lambda. In other words, they're asking us to solve for wavelength. Okay, so they tell us our speed. They tell us our speed is 50, and they tell us our frequency is 100. So I just plug everything in. Okay, now I want to solve this equation for wavelength. How do I do that? How do I solve this equation for wavelength? Remember, in order to solve this equation for wavelength, in this case right here, it is the opposite of multiplication. It's dividing. So I'm going to divide this side of the equation by 100. That goes away. Whatever I do to one side, I have to do to the other. Okay. What is 50 divided by 100? That is 1/2. Or in other words, 0.5. So here my wavelength, and guys, please get your units right. Wavelength is a measure of distance, so wavelength is always in meters. Okay, keep it in mind. Wavelength is in meters. Okay, so here our answer is 0.5 meters. Okay. I got 3 more problems that I want to do on another page. Let me go ahead and pull it up now. 3 more problems to do, and then I'm gonna let you guys go for the day. I just want to do enough examples with you guys. That way you guys know how to do the homework. Okay, look at this. Look at this problem right here. Guys, on some of the problems that you're going to have on your homework, it's going to give you period, and it's going to ask you to find wave speed. So in this example right here, it says if a wave has a period of 20 seconds and a wavelength of 10 meters, what is its speed? Okay. So again, guys, you all know that the equation for the speed of a wave, speed is equal to wavelength times frequency. Okay, you guys already know that. Okay. But guys, notice they didn't give us the frequency, they gave us the period. But guys, remember, we can easily find frequency if we know the period, because remember, frequency is equal to 1 divided by the period. We just said that, okay? So if I want to find my frequency, I'm just going to do 1 divided by 20 here, okay? Well, what is 1 divided by 20? 1 divided by 20, that is 0.05. 0.05. So my frequency here is 0.05 hertz. Okay. 0.05 hertz. Okay. So now that I have my frequency, then I can just plug into this equation here to find the speed of the wave or its velocity. So in this case right here, the wavelength is 10 meters. Okay. We just found the frequency, which is 0.05 hertz. So if I do 10 times 0.05, that gives me a speed of 0.5 meters per second. Okay. All right, let's do two more examples. Okay. So look at this example right here. It says if a wave has a period okay. Okay. So this example right here says if a wave has a period of 100 seconds and a wavelength of 250 meters, what is its speed? Okay. So the equation for the speed of a wave is equal to wavelength times frequency. Okay. So remember, guys, if we know the period, we can easily find the frequency because frequency is just 1 divided by the period. Okay. So if my period is 100 seconds, so 1 divided by 100 is equal to 0.01. 0.01 hertz. So my frequency is 0.01 hertz. So now I just plug into this equation here for speed. Speed of my wave is equal to my wavelength, which is 250 meters, times my frequency, which is 0.01 hertz. Okay. So 250 times 0.01 hertz. That gives me 2.5 meters per second for my speed. Okay. Okay, so hopefully everybody got that. Okay, again, I found my frequency first and I just plugged it into this equation. Let's keep going. It says, okay, this is the last one. What is the wavelength of a wave that has a frequency of 65 hertz and a speed of 350 meters per second? Okay, so here we're being asked to find wavelength. So I'm gonna write down my equation for speed. Speed is equal to wavelength times frequency. So I know the speed is 350 meters per second. I don't know the wavelength, but I do have the frequency. The frequency is 65 hertz. Okay. So how do I solve this equation for wavelength? Again, this symbol here in lambda, that just means wavelength. So I would, divide this side of the equation by 65. That goes away. Whatever do to one side of the equation, I have to do to the other. Therefore, 350 divided by 65 is equivalent to my wavelength. Okay, it's equivalent to my wavelength. So if I put that in my calculator, 350 divided by 65, I actually get a wavelength of 5.38 meters. Okay. So my wavelength is 5.38 meters. 5.38 meters. Any questions on using the speed equation? Okay, I think I've done enough examples for you guys to be able to do the assignment. Guys, as soon as I get done with the Zoom call, give me about 10 minutes because I have to do a few tweaking to this assignment and then I'm going to make it available to you guys. Okay, for people who did not fill out the attendance form, can you guys click on that and get that filled out for me before you leave? Okay, are there any final questions before I let you guys go? Okay, guys, if there are no final questions, you guys are free to go. I hope you guys enjoy the rest of your morning. Bye, guys.